Hey everybody, so we are here on another day of probability. We're looking at simple events today. One thing that I do want you to know, we are going to look at a deck of cards. Those are going to be what a lot of your problems cover. So if you're not sure about a deck of cards, I do have an image at the bottom of these notes, but please feel free to Google deck of cards and there's lots of options out there for you, but we are going to use a deck of cards to go through quite a few of our examples. So if you're unfamiliar, please familiarize yourself with them, and I'll do my best here at the end of the notes to cover the important stuff on deck of cards. Okay, so we've got some probability information here. Probability in general is used to measure how likely an event is to occur. Okay, so that's our first fill in the blank. Meaning if you have a very low probability of something happening, depending on what it is, you may or may not decide to do it. If you have winning the lottery, very low probability. So I don't play the lotto because of that. So your probability is definitely just about how likely something is to occur. Okay, so the set of all possible outcomes is called your sample space. So those are every outcome that is potentially there. And for equally likely outcomes, sometimes you hear people say the phrase, there's a 50-50 chance. They're equally likely. The theoretical probability of an event, so I want you to notice how it is P of E is the ratio of the number of favorable outcomes to the total number of possible outcomes. So it's always in your favor over what is possible, okay? Favor to total. So that's what your theoretical probability is. So this will make more sense here because you've been doing probability, some of these basic things for a long time. So we've got a jar containing 32 red, 28 blue. What's the probability that a randomly selected marble is red? So if we're doing a ratio with probability, it is your total outcomes that you want. So this is where we called it your favorable outcomes. Well, we want a red one, so I have 32 reds to choose from. And then, but I don't only have red in my marble jar, so I need to add up 32 plus 28. So that's going to give me a total of 60 marbles in my jar. So 32 plus 28. And what you'd want to reduce, you always want to reduce. So I would take out a 2, so I would get 16 over 30, take out another 2, 8 over 15. So I would say that my probability is 8 over 15. Example number 2, we have a letter in the word restoration is randomly selected. What's the probability of selecting a vowel? So first thing you'd have to do is you'd have to count your vowels. So we have, there looks like there are 5 vowels in that word, but there are also consonants. So you have to count your total number of letters in that word, and there are 11 letters. So it's vowels, how many choices you want to happen, or how many options do you want to happen over what is possible. So it's always what you want over what's possible. Okay, a day in the month of January is randomly selected. What's the probability of selecting a prime number? So here's the crazy part. You need to remember that 2 is prime. I believe 2 is the only even prime number. By definition, a prime number is only divisible by itself and 1. So most of the time we only see odds in there, but 2 is prime. You do need to remember that. So in the month, when you're counting 1 through 31, there are 11 prime numbers, but there are 31 days in the month of January. So what I want over what's possible. And we could continue looking at this. Okay, so then we have something called the complement of an event. A complement of an event is the probability of the event not happening. So what's nice about probability is your situation happens or it doesn't. It's black and white. It either happens or it doesn't. There's no gray area of, well, like maybe it happened. It either did or it didn't. So the probability of the event not happening is called your complement. Since the sum of all probabilities in a sample space is 1, okay, remember, it either happens or it doesn't. So if you have a 40% chance of it happening, you have a 60% chance of it not happening. 40 plus 60 is 100%. 100% is 1. Okay, so all probabilities are between 0 and 1. 0 means it will never happen. 1 means it will always happen. And if you look at all of your fractions always are going to be a fraction less 1 or less, something in between 0 and 1. It's never going to happen to it's always going to happen. Okay, so 0 is unlikely and 1 is certain. Okay, so unlikely to certain or never to certain. So what we're looking at is if you are trying to find the probability of an event not happening, you're going to take 1 minus the probability of the event actually happening. Okay, so it says problem number 1, the probability that it will snow tomorrow is 7 out of 20. So what's the probability that it won't snow? Well, you can do 1 minus 7 out of 20, which is going to give us 13 out of 20. So the probability that it won't snow is 13 out of 20. The month of the year is randomly selected. What's the probability of getting a month that does not begin with the letter A? Okay, so we've got, let's see, how many do begin with the letter A? Okay, there's only April and August. So I'm going to take 1 minus, take out those April and August days, and we're going to be left with 10/12, which we're going to reduce that to be 5/6. Okay, so that's your complement. So let's move forward. When we're looking at compound events, there are independent versus dependent. Independent means one does not affect the other. Okay, so you're looking at the probability of rolling a die and picking a card. The outcome of my die rolling does not affect the outcome of my card picking. So they're two independent events. So if they are independent, what you're going to do is you're going to do the individual probabilities, the probability of the first event happening, and then you're going to multiply it by the probability of the second event happening, and means multiply. But sometimes you do have dependent events where the first outcome does affect the second outcome. Meaning if I start with a deck of cards and I pick a card and I say I am not putting it back in the deck, so it's called not replacement, my second probability is absolutely affected by the first outcome. Okay, so there's independent where they're not affected by each other and dependent where they are affected by each other. So how we do this second one is it's the probability of the first event. So go ahead and pick that first card, pull that first marble from the jar, roll that first die, whatever you're doing. But then you're going to multiply it by the second probability, but what the probability would be after the first event has happened. Okay, so let's look at a couple independent events. So we've got a die is rolled 3 times. What's the probability of getting 1s on each roll? Well, if you roll a die and then you pick up that die, that first roll has no effect on the second die, or the second roll, I should say. They don't affect each other. So of me getting a 3, a die has 6 sides. There's a different number on each side. So my first roll, I would have a 1 out of 6 chance of getting a 3. And means multiply. My second roll also has a 1 out of 6 chance. And my third roll has a 1 out of 6 chance. So I would multiply all of those together and I would get 1 out of 216. Okay, so then we have a situation, number 12, a coin is tossed, then a day of the week is selected. My coin toss has nothing to do with the day of the week. Okay, they're two totally independent things. What's the probability of getting a tails and then a day starting with the letter T? Well, My coin toss, getting a tail, is 1 out of 2. And then my next one, picking a day that starts with the letter T, we've got Tuesday and Thursday. So I have 2 choices out of the 7 days of the week. So I would get 2 out of 14, which ends up giving me a probability of 1 out of 7. Next scenario, we have a bag containing 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. So I will just give you guys some information here. There are a total of 32 crayons in there. So what I want you to pay attention to is a crayon is selected, then replaced, and then another is selected. Because your original crayon was put back in the bag, the first pick does not affect the second pick. If it was not replaced, which we're going to get into next, it will affect. So that changes it from being an independent event to a dependent event. So let me do one of each type. So for question 13, it says a purple, then a yellow. So what we're looking at is the probability of picking a purple. Well, purple is 14 out of the 32. And then yellow. So it's an and in there is implied. So I would multiply. We've got yellow would be 6 out of 32. Because it was replaced, it doesn't affect. So we're just going to multiply straight through. When I multiply through and when I reduce, I would get a final answer of 21 over 256. Okay, if you are doing 2 of the same type, I would do 14 out of 32. Times 14 out of 32. Because it's getting put back in there, you technically can pull the same crayon twice. And that would give me, in the end, 49 out of 256. So switching my situation, if it is not replaced, so same number of crayons, same in the bag, but when I pull out that first crayon, it stays out. So this would be dependent because it changes. So if I want a yellow and then a red, if you go back up, there were 6 yellows out of the 32 crayons in the bag. So I pulled out that yellow crayon. So I took out the yellow. It's now gone, no longer in the bag anymore. Now I have red. So there are still 8 red crayons in there, but now my denominator changed because now there's only 31 crayons in the bag. So it does change my probability. When I multiply that and reduce, it would become 3 out of 62. Now, if we do 2 reds, I would do the first red. There were 8 reds in my bag out of 32. So I would pull a red out and I would leave it out of the bag. So that would mean that now there are only 7 reds in my bag and 31 crayons. Okay, so last but not least, guys, we're going to be working with cards. I just want to go over, here are all 52 cards. This group that literally has faces on them, these are called face cards. There are 12 of them. Okay, there are 4 suits. Each row is a suit. These are called clubs. These are called spades. These are called hearts. And these are called diamonds. Okay, and within each suit, there are 13 cards in each suit for a grand total of 52 cards. Half of them are red, half of them are black. So again, familiarize yourself with these decks of cards. We're going to have some questions on them, and but please feel free to use these notes or go ahead and Google yourself deck of cards, and you'll see lots of different options on there. Okay, so have a great day, guys. We'll see you soon.